Howdy everybody, this is Nighttime Mathematics Radio. We're coming to you live from our secret base here by the bay. If anyone has any math questions, feel free to tweet them through to Twitter and we'll answer them as we come. So the plan to this is to offer live math help over the internet, so if anybody has any questions, ask them on Twitter or ask them in our chat room here on YouTube, and we'll be happy to try to answer them. Keep in mind that because we're streaming over the internet, we've got about a 30-second delay between what we say and what you hear. So if you ask a question, don't be offended. If I don't respond to it right away, we'll be reacting to it once we get it. Now, in the interim, while we're waiting, let's take a look at a a calculator that's on the opposite end from the TI-84. So here on my notepad I have a TI-30XA. This is a very inexpensive calculator. This is on the opposite extreme from something like, say, the TI-84. This one costs about $12. But it's quite capable. It can do most of what you'll need to do in most classes, from physics to chemistry to most math classes. But I've had a lot of students over the years have trouble with it, and the reason is it's a very old-fashioned calculator. In particular, the way it displays scientific notation is very strange. So let's say you have a number in scientific notation you want to write, like say Avogadro's number, 6.02 times 10 to the 23rd. So we got Avogadro's number, 6.02 times 10 to the 23rd. So suppose we want to encode that in the calculator. Well, the way we do that is that we would type 6.02 E23, and that really looks wrong. That looks like 6.02 times. That looks like 6.02 to the 23rd power, which is not at all what we want. But that's not what that is. It turns out what this is showing here, that little 23 up there means times 10 to the 23. That's very confusing, and a lot of students get that wrong. What a lot of students will do is they'll type 6.02. Oops, let me clear this out. They'll type 6.02 times 10 to the 23rd power. And that looks completely right until you hit equals. And the problem is the moment you hit the equals key, we notice that exponents turn into 24. Because remember, what EE means is not to the power of, but times 10 to the power of. So when we typed 6.02 times 10 EE23, we weren't saying times 10 to the 23rd power. What we were saying was times 10 to the 23rd power, times 10 to the 24th power, which is what that shows us. That's a real danger. That's something students get wrong all the time. So, as you go forth to use the TI-30XA in your science classes, it works perfectly well. You just have to be careful. Now, when it comes to scientific notation, there's a few modes you can put this thing in, which are really useful. The first is, if you look above the 4, 5, and 6 buttons, you'll see three labels up above it: flow, psi, and eng. Now, what those are for is flow is floating point. That means it will try to display things on a screen in a way that makes sense to it. So, for example, if you type 0.01, it will display 0.01. If you display 0.001, it will leave it as such. But if you put a lot of zeros in there, it will say, I guess that works too. Divided by 10. Still lots of zeros, divided by 10. And now finally it gives up a user scientific notation and says that's 10 to the minus 10th power. And again, remember, 1 point, then with a minus 10 up there, on this calculator means 10 to the minus 10th power, or 1 times 10 to the minus 10th power. Again, that's an easy mistake to make. All this isn't great. There's a problem is if you get an answer like 0.000025, that's not normally what you want. You want that in scientific notation. To do that, if you type second psi, and as soon as you push that, you'll notice it says, great, 2.5 times 10 to the minus 6th power. Psi means always prefer to put it into scientific notation. Even if it could fit it onto its display, it assumes you probably really want scientific notation here. The other option, which won't show up this time, let's put another one at 0.01, that's 100th. If I do psi again, I'll do 10 to the minus 2, 1 times 10 to the minus 2, or 1/100th. To do eng, on the other hand, it says 10 times 10 to the minus 3. What eng does is it does a sort of variation of scientific notation where it prefers to use powers of 3 up there, so multiples of 3. So this time, why is that useful? Because remember, multiples of 3 in the exponent correspond to metric prefixes. So, for example, if this was in meters, then this would be 10 to the minus 3, or millimeters. If it was 0.00001, it will let me say that's 10 times 10 to the minus 6th, or 10 micrometers. So eng is useful in a lot of science classes in that it will give you something you can immediately put into a unit with a metric prefix, and that's incredibly helpful. So I'll go back to the floating point. And of course, in floating point, since that fits onto the screen, it doesn't bother with scientific notation at all. It just says, that fits onto my display, here it is, 0.00001. As we go on with the show, I'll keep talking about more tricks on this calculator. The TI-30XA is an amazingly capable calculator, but it's got a lot of features people don't understand how to use, and so they almost never do. So we'd like to cover that over time. So here we are back on the Terror Triangle. Once again, if anybody has any questions, feel free to ask them on Night Math Radio, on Twitter, or in the chat room on this YouTube video. Let's see, it's now 10:39 Pacific time. If we get any viewers, I'll keep the show going. Otherwise, I'll stop the show at 10:45. So once again, the Twitter channel here is at Night Math Radio. That's NIGHTMATHRADIO. The YouTube channel here has its own chat room. You're welcome to use that as well if you prefer. So just feel free to ask a question wherever you'd like. Well, while we're waiting for questions, perhaps we should go back to the notepad for a bit here. Let's look at the calculator again. Now, the calculator has a bunch of other features. One of them's on most calculators, but it confuses a lot of students, and that's the DRG thing. What this does is it switches between, you notice it says up there deg. That means right now, sine, cosine, and tangent, for example, are designed to use degrees. So, for example, if I want to know what sine of 30 degrees is, or that would be 30 sine, 0.5, as you'd expect. Now, that's one option. This is most obvious when I go into inverse trig functions. So I say 0.5 second sine says sine of what is 0.5? The answer is 30 degrees. Now, there's three ways of describing angles that are used in common usage. One is degrees. This is something everybody's familiar with. In degrees, we define a right angle to be 90 degrees. Why? Because 90 is divisible by a lot of things. The entire reason why we have 90 there is just that 90 is divisible by 2, it's divisible by 3, it's divisible by 4, it's divisible by 5. It's divisible by 2, it's 3, it's divisible by 5. Not by 4. It's divisible, but it's got lots and lots of divisors, so 90 is a really handy number for that. Now, there's two other ways of doing angles. A second one, which you might have seen, is you say, well, let's take the angle, say whatever this angle might be, say a right angle, and then imagine a circle. So let's take the circular arc, whose opening angle is the angle we're interested in. And now we say, well, gosh, we've got two lengths here. We've got this length here, which is called a radius. And we've got this length out here. Well, that's a quarter of a circle. If it were full circle, remember, it would be 2 pi r, or pi times the diameter. That's what pi literally is. But we've got a quarter of a circle. So instead of 2 pi r, it's pi r over 2. And so the idea here is to say, well, if we want to measure this angle, why don't we use something dimensionless? Let's use something which doesn't have any units in it at all. And one way to do that is to say, let's take that length of that circular arc, pi r divided by 2, and divide it by the radius. That'll cancel out the radius, and we'll get a pure number, just pi over 2. So What is pi over 2? Well, we can compute that very quickly. There's a nice pi button on our calculator. Pi divided by 2 equals 0.15707. We can sort of remember that. So don't remember in degrees mode. So if I say, well, remember the sine of 90 degrees is 1. So if I say, what's the inverse sine of 1, I'll get 90 degrees, as we'd expect. But if I push this DRG button, it now shows rad up there for radians. Radians are those units I just described. A radian is a unit described by taking the circular arc length and dividing it by the radius to get the angle measure. That's pi over 2. So now that we're in radians, if I say, what's the inverse sine of 1, I get pi over 2, 1.57079, just like we saw before. There's a third measure up there, grad. And most students, when they see this, say, I've never seen this before. And that's actually funny, because this is one you see probably most often. The reason is you see this one when you're driving. Sometimes when you're driving, you'll see a little sign that says something like, caution, 15% grade. If you wonder what's it saying there, that's actually an angle measure. It's telling you how steep the hill is that you're coming up on. What it's telling you is that's 15% of a sheer cliff. So a straight road is a 0% grade. An absolute cliff is a 100% grade. So sheer cliff there is a nice 100% grade. And anything between it, say a 45-degree angle, that could be a 45-degree angle, but it's also a 50% grade. So in particular, if we say, let's say we want to know what the inverse sine of 1 is, for example, now that we're in gradients, it'll say 100. It's a 90-degree angle is 100% grade, sine of 1. How about a 30-degree angle? Well, let's find out. Remember that has the inverse sine of that has a sine of 0.5, so the inverse sine of 0.5 now is 33.333, or a 33.3% grade, which makes perfect sense, because that's 1/3. And indeed, a 30-degree angle is 1/3 of a sheer cliff. So that's gradients. Which one is most useful? Well, it depends on the situation. If you're working in a shop, for example, in most shops, most of the angle measures you'll see will be calibrated to measure in degrees, so degrees will be what you want. If you're working on road construction or something, then obviously gradients are what you want, or if you're doing something else that uses gradients traditionally. The two I'm aware of are artillery fire and roads. There may be others. If you're doing mathematics, it turns out, for reasons that you'll see over time, the radian is actually the single best measure to use for doing actual mathematics. Why? Well, if you're in pre-calculus now, you'll see it in calculus, and if you're in calculus now, you already know. Well, it's 10:46 here. This is Nighttime Mathematics Radio. I'm going to sign off for the night. We'll try this again next week. See you next week, everybody.